All right, this is the second time. I'm not making everyone say it again. So, related rates, pause the video, read this, and we're talking about taking derivatives right here with respect to time. That's going to be our big key here. All right. So it says a golfer hits a ball into a pond of still water, causing a circular ripple as shown in the figure. If the radius of the circle increases at a constant rate, okay, of 0.5 meters per second, how fast is the area of the circle increasing with the radius of the ripple is 2 meters? Okay, there's a lot of things going on right here. So let's start with the first one. Radius of the circle increasing at a constant rate. So, of the circle, are we dealing with, let's see, how fast is the area of the circle? Okay, so area of a circle, so it's going to be pi r squared. So there's a couple things that we're going to have, okay, in that one. And also, and it gives us the rate that says constant rate, it is 0.5 meters per second. So 0.5 meters per second. So that is increasing, radius is increasing, so that is dr dt. That's the radius increasing over time, right, is equal to 0.5 meters per second. Next one right here. And right here, the area of the circle, when the radius is 2. And that's going to give me an r equals 2. Now, as we go through and look at these problems, that's what you need to do every single time. Read through the problem multiple times, figure out the formula that it's asking for, because quite often you're not just going to have an area formula, you're going to have an area, a volume, a circumference, all of those together. But if you think about it, a circumference formula, anyone recall circumference formula? 2 pi r, very good. Okay. Area formula? Pi r squared, right? Okay. And volume formula has, of a sphere, let's say it's a sphere, right? The volume would be 4/3 pi r3 cubed. Yeah. So all of those formulas there have what in common? They have an r. And so we could actually use each one of those formulas because they all have a r, and I could flip them back and forth for different things that I'm changing. But the r is going to change specifically. I have a rate of change, and I could adjust and look at the volume, the area, the circumference, all at that time, which this one gives me a radius of 2 meters. Does that make sense now? Kinda? So, label everything. Write out what we have and label everything. That's going to be key. So, I'm going to start off here, and area is increasing. Okay, so how fast is the area increasing? So that is the speed of the area. Speed of the area means rate of change, right? So I'm looking for come on. Oh, this thing sucks. This is gonna be like the hardest thing ever. Gotta be difficult today. So I'm gonna try and do the little mouse thing and draw with my mouse. So I'm looking for dA over dt. So that's going to be my end result. It's asking for, in that formula, this is what I'm looking for. So let's go through, and I'm going to have to find the area, and I'm going to use this formula right here, and I'm going to use that to take the derivative. So as I take the derivative, it's going to give me a dA dt Now, if I'm taking the derivative of this, okay, remember when we did implicit differentiation, right? If I'm taking the derivative of something that is not the variable, and what is my variable in this case? Time. Time is going to be the variable for almost every single related rate. They're always going to be in times. So that's why it's a dA dt. So I'm taking the derivative of the area in terms of time. So right here, if I take the derivative of this, if I take the derivative of this, what am I going to get? Is pi a variable or a number? It's a constant number, right? Okay, so that means that one's just going to stay. But what if I'm taking r squared? Take the derivative of r squared, I get to what? To r. So it's 2, bring down my pi, my r, and did I take a derivative of something that's not my variable? Say yes. I took the, remember, what's the variable in all these? Time. So if it's not my variable, when I learn it with implicit, I need to add a dr dt. This is getting so bad. I guess I'll do it now. 2 pi r times dr dt. There we go. Yeah, that nasty thing right there is a pi. Sorry. Wish I could say it's just my penmanship. So that means I'm looking for dA dt, right? That's what this over here said. I'm looking for the rate that my area changes. The area over time. That's dA dt. So that's the area changing. Do I know what the r is? Yes, I know what r is going to be. What is my r going to be? 2, because that's what we did when we went through and listed everything. What is my dr dt? It's my 0.5, right? Okay. So do I have enough information here to get my dA dt by itself? Yeah. So let's see. So dA dt is equal to 2 pi times 2 times 0.5. So my dA dt is going to be equal to 2 pi. What are my units? What are my units here? I almost heard. I'm sorry. The fan is like, I have an ear infection, so I can't hear it anyway. But this is like making it worse. There we go. Okay. So speak louder. What do we got? Meters per second. Okay. What does the dA stand for? Of the, what is the A? Area. Area is squared. Area is squared. So if it's dA, my area, my units are going to be squared. So this is going to be meters squared per second. It's not so bad, is it? It seems weird, but we're just plugging in. So reading the problem is probably one of the bigger problems that we have. Yeah? No? Maybe? Okay, let's do it. Let's do another one. Okay, steps for solving a related rate problem. Read the problem carefully, perhaps several times. Pay particular attention to the rate you are asked to find. If possible, draw a picture to illustrate the problem. This is going to be one of the key things. Drawing pictures. Like, I suck at regular math. I really do. I have to draw a diagram for almost everything I do. Any of the problems that we do, if there's a word problem, I need to try and draw something to have a information and plug in my information where they go. Because just doing that little thing, you might realize that ladder leaning up against a wall is a right triangle. After you draw it, you could notice, oh, it's a right triangle. What do we know about right triangles? I know I could always use Pythagorean theorem to find the missing side of a right triangle. I know that the hypotenuse, which would be the ladder in this case, must be the longest side of this right triangle. I know that my leg of my right triangle cannot be longer than the hypotenuse. Otherwise, the ladder's just laying on the ground. Right? By drawing the picture, you could see things like that. And so in your information, you're building up your own information off of it. Identify variables, assign symbols to them, label them with a picture, identify the rates of change as derivatives, be sure to illustrate units for each variable and each rate of change, indicate what is given and what is asked for, write an equation that relates to the variable. It may be necessary to use more than one equation. Differentiate both sides of the equations, substitute numerical values for the variables and derivatives, solve for the unknown rate. A spherical balloon is inflated at a rate of 10 meters cubed per minute. Find the rate at which the surface area of the balloon is increasing when the radius of the sphere is 3 meters. All right, go ahead, read that again, and I want you to write out what information you are getting out of that. Just like we did on that first example. pi r squared. Surface area is 4 pi r squared. Okay, well, you need, no, you need to write the whole thing. Okay, see what I did here? Okay, so I started with an area, and then this is what it gave me. So it said the change in the, what's that? Okay, is that. So change in the radius, and then you had a radius. So that's important, and it also, there was another one that said, what are we looking for? We were looking for dA dt. Nope, that's from the thing. You want to list what you have and what you're looking for. Are you already working on it? Or R is here. Okay, right here, you have to write it like this with the notation. Because there's going to be multiple, so you're going to have like a B prime, R prime, a C prime, all those. So write it with the corresponding time that we're doing, okay? Because you're going to have some problems coming up later on that you're going to actually not be by time. You're going to be radius or something crazy, okay? Is that your answer? Where'd you write it out? So I could just make sure you wrote it out correctly. Okay, where'd you start this off? Okay. And where are you listing all the information? I don't. No. List your information. No, list your information. List the information given to you. Like I did on the first problem. Did you not write down the first problem? Nope, you didn't. So, yeah. Alright, so go through. Okay, reading through here. Inflated rate of 10 meters cubed per minute. Now meters cubed is important because that's telling me that that is a volume. That's important. Those are key things that as we read through here. That's a volume. So since I'm dealing with a volume, I know that my volume okay, so since I'm dealing with the volume, I know that. I also know that I have my derivative, my rate of my volume is going to be 10 meters cubed per minute. Find the rate, which is surface area. So that's another one. Surface area. So my SA, my surface area is equal to 4 pi r squared. Area of the balloon is increasing. So find the rate in which that the surface area of the balloon is increasing. So that's the rate of the surface area. So that is surface area. It's usually ds but I'm putting surface area to make sure you guys know, and dt is what I'm looking for. That's the end result. And when the radius of the sphere is 3. Now, everyone should have at least that much information on your paper. When I said write it all out, because this is going to give you those points that we're trying to get on the AP type questions. So always have everything listed so you have your variables so you can go through and mark everything that you do know. So my end result. So I need to actually take my surface area and find the derivative of the surface area. Okay? So derivative of the surface area so it is going to be so there is the derivative of the surface area. So I need to figure out my dr dt. So I know what the r is, but I don't know anything for my dr dt, right? Okay, so we're going to use the volume formula now. My volume is 4/3 pi r cubed find my derivative there. I get derivative of the volume dt is equal to 4 pi r squared dr dt, because I took the derivative of r in terms of the time. This is super annoying. There we go. Do I know what dv dt is, though? Do I have a number for dv dt? What is it?
10 meters cubed per minute.
Okay, so I could replace dv dt with 10. That's going to be important here. 10 equals 4 pi There we go. 4 pi. Yeah, I'm getting a new one today. I'm gonna go find me one. What's my r? 3 squared. There we go. By plugging into my volume formula, I'm able to isolate and get my drdt by itself. So what's this going to end up being? It's going to be 936 10 over 36 pi not tau equals dr dt. So now that I know my drdt, can I plug that back into my volume formula? Say yes. I could plug that back into my volume formula. So I'm going to do that. Because my end result is looking for my surface area, isn't it? Okay, so I have the drdt for that, and I have surface area, which that's my end goal. So let's see, since I now know my r and I now know my drdt, so I could get my ds dt by itself now. So I'm going to say ds dt is equal to 8 pi, my r is 3, my dr dt is going to be 10 over 36 pi. Yep. Alright, do a little bit of math. So let me see, what's that going to do? That's going to go bam, bam, 12, what's that? 5, 6, 4, 3, yeah. So my ds dt is equal to 20 over 3, because these pi's on top and bottom will cancel. What are my units? What is it? Meters squared per minute. Very good, because it is my surface area, which is my meter squared. Per minute. Now, I know it's kind of annoying and it's really distracting to try and fight with the smartboard while we're doing this, because, you know, what can we do to actually try and make calculus a little bit harder? Make a smartboard not work and, you know, have to keep going back and rewriting everything. Questions over any part of this? Because I'm going to leave off here today. Any questions? Now, do you guys understand the reason why I asked you to specifically label everything? You got to do your units correctly every time, because that's going to make a change. If you notice, the only indication that we're going to have meters squared as an answer is in my information. It says as with my area, change in my area. So the units is actually going to be a big thing of your grade. I'm pretty sure the units are going to be 1 point itself on the AP exam, as long as you get the units right. All right, everyone's going to make sure they like, share, and subscribe, and I will do my best to get a new smartboard. All right, peace out. Yes.